At this point, now that we've gone over our first 4 rules of inference in 7.1, it's quite likely that you're wondering why the heck do these rules work? What's so special about modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism? What are they about exactly? And why is it not the case that we can't just use some other rule? Well, the explanation here is a rather simple one, and it relates directly to what we did in the previous chapter, in chapter number 6. Modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism all work because they are valid argument forms. That's a term from chapter 6, also dating all the way back to chapter number 1. Valid just simply means that if we accept each of the premises as being true, then the conclusion, what we derive from those 2 premises, as the case might be, what we derive from those, according to our rules, must also be true. And that's the very definition of valid. If the premises are true, the conclusion must be true. We can demonstrate this for each of our 4 rules here in 7.1 by using, once again, a truth table from chapter number 6. So let's take our first rule, modus ponens, and I won't go through all 4 rules here. You can do that for yourself. But it will give you a good indication, a good sense of why these rules work, and why we're not dealing with some other construction here. So let's take modus ponens. Our first line is A horseshoe B, and I'll separate these out using a single slash, separating out premise 1 from premise 2. Our second premise is in fact the antecedent A, and what we're claiming here is that we ought to be able to get out the consequent B. So count up the number of unique variables, in this case 2, we've got A's and B's, just 2 unique variables. So plug that into our formula, L equals n to the power of 2, so 2 to the power of 2 is 4. 4 lines in our truth table, take that number, divide by 2, 4 divided by 2 is 2. So on the far left hand side, we'll start with 2 consecutive t's, followed by 2 consecutive f's. Every time you define a variable, define it in the exact same way. This all ought to sound quite familiar to you. So the second appearance of A, T, T, F, F, and that just leaves us with one other variable to define, in this case, B. So to define our first variable, we start with 2 consecutive t's, take that number divided by 2, 2 divided by 2 is 1. So to define B, we'll just start with a single t, followed by a single f, and repeat that process until we fill up all 4 lines. Once you've defined a variable, define it the exact same way, tf all the way down. Now, without thinking about it at all, we've got our truth table. So here we solve for each of the premises as well as the conclusion individually. Easy enough to do in that the conclusion is already done, so I'll just circle that on. And our second premise is also done as well. So we just simply need to solve for our first premise, A horseshoe B. T horseshoe T is true, T horseshoe F, that's a special case, false. F horseshoe T is true, and F horseshoe F also true. So we'll circle that column as well. And you'll see here, if the 2 premises are true, which is the case here for line number 1, if the 2 premises are true, 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 then the conclusion must be true. The conclusion must be true. Therefore, using our test from chapter 6, using our truth table, we see that modus ponens is valid. Let's go through another rule, so-called rule. Seems as though it ought to work, but in this case, you'll see that it's invalid. Therefore, it's not introduced in 7.1. You might think that this might work. It looks good enough. What if we had A horseshoe B, and this time, instead of, as a premise, the antecedent, what if we had just the consequent B, and we tried to get out the antecedent A? Let's construct our truth table. In fact, it will be the exact same truth table, really. 2 unique variables, 4 lines. So for A, define it the exact same way, T, T, F, F. Every time it appears, T, T, F, F. Which just gives us B. We'll alternate here, T, F, T, F. Just as was the case in our first example, the second premise and the conclusion are defined for us, so that just leaves us the first premise, T horseshoe T, true, false, true, true, circle the column under the main operator, and here you'll see that it is possible, you'll see this in line number 3, it is possible for for both of the premises, as is the case in line 3, it is possible for both of the premises to be true, and yet the conclusion to be false. So this might look like it should work, but in fact, as we see using a truth test from chapter 6, that this would be invalid, whereas modus ponens is valid. So modus ponens, modus morons. Don't be a modus moron. And you can go through the same exact text for the remaining 3 rules in 7.1, and you'll see that those that are given to us are in fact valid according to our truth tables. So that's why these rules work. If we accept the premises, then the conclusion must be true. And if we know that the initial starting point is true, the initial amount of information given to us is true, and we apply the rules correctly, then whatever we get out will in fact be true. In that sense, these rules are truth preserving. If we start with something true, what we get out as a result is true. And that's just a quick explanation as to why they work, and to connect the 2 chapters, chapters 6 and 7.